There's this fundamental rule of math that's pretty much hidden in plain sight all around us. I'm talking about in the buildings we see, the screens we're staring at right now, even in the GPS that gets us around town. It's the Pythagorean Theorem, and by the time we're done here, you'll see how this one simple idea about triangles holds the key to solving some really cool and complex problems. Okay, let's just dive right in with a little puzzle. Forget about dusty old math books for a second. Instead, picture a modern city skyline. Maybe you're a high-wire artist, or hey, maybe you're just planning the most epic zipline ever. So here are our two buildings. You've got Block P, which is 32 meters tall, and right next to it, Block Q, which is 41 meters tall. Now we know for a fact that the distance between them on the ground is exactly 12 meters. Here's the challenge. What's the direct, straight-line distance from the top of one roof to the top of the other? I mean, think about it. You can't just stretch a giant measuring tape across that huge gap in the air. So how do you figure out that length? It seems almost impossible, right? But the solution is actually surprisingly simple. Well, the key, the secret, is this incredibly elegant 2,500-year-old mathematical principle. It's like a secret code that turns this impossible-looking riddle into a totally doable calculation. And here it is, the Pythagorean Theorem. All it really says is that for any triangle that has a perfect 90-degree corner, what we call a right angle, there's this amazing fixed relationship between its three sides. Basically, the length of the longest side, squared, is always equal to the other two sides squared and then added together. Always. Okay, so to really get this, we've got to know the lingo. The two sides that meet to form that perfect right angle, we call those the legs. We usually label them A and B. And that longest side, the one that's always opposite the right angle, has a special name, the hypotenuse. We'll call that one C. And all of that brings us to this famous little formula. But here's the really cool part. It's not just about length, it's about area. If you imagine drawing a square on each side of the triangle, the area of the A square plus the area of the B square will perfectly equal the area of that big square on side C, every single time. That visual relationship is what gives us the equation. A squared plus B squared equals C squared. That is the secret code we need. Okay. Before we get back to our rooftop problem, let's just do a quick, classic example to see this thing in action. First up, we'll try to find the hypotenuse when we already know the lengths of the two legs. So check out this triangle. We know the two legs. Let's say side A is 3 units long, and side B is 4 units long. Our job is to figure out the length of the mystery side, C. It's super straightforward, we just follow the steps. We start with our formula, A squared plus B squared equals C squared. Then we just plug in the numbers we know. So 3 squared plus 4 squared equals C squared. Okay, let's do the math. 3 times 3 is 9, and 4 times 4 is 16. So 9 plus 16 gives us 25. That means C squared is 25. To get C, we just find the square root of 25, which is 5. And there's our answer. Easy, right? Awesome. But what if this situation is flipped? What if you already know the longest side, the hypotenuse, but you're missing one of the shorter ones? No problem. The theorem is flexible. Let's see what happens when we solve for a missing leg. So, take a look at this triangle. This time, we know the hypotenuse, C, is 13. And we also know one of the legs, let's say B, is 5. But we have no idea what the length of the other leg, A, is. The process is pretty much the same. We start with our trusty formula, A squared plus B squared equals C squared, and we pop in our numbers. That gives us A squared plus 5 squared equals 13 squared. So A squared plus 25 equals 169. To get A by itself, we just need to rearrange things a bit. We subtract 25 from both sides, which tells us that A squared is 144. And the square root of 144 is 12, so our missing leg is 12 units long. All right, the warm-up is officially over. We've got the tools, we know how to use them. Now we can finally go back and solve that rooftop riddle we started with. Let's look at our buildings again. Do you see it now? The problem was hiding a right-angled triangle from us this whole time. The horizontal distance between the buildings, well, that's one leg. The difference in their heights is the other leg. And that distance we want to measure between the rooftops, that's our hypotenuse. Okay, let's break it down. First, we need the height of our hidden triangle. That's just the height of block Q minus the height of block P. So 41 minus 32. That gives us 9 meters. That's our A. Next, the base of the triangle, well, that's just the distance between the buildings, which we know is 12 meters. That's our B. Now we just apply the theorem. 9 squared plus 12 squared equals C squared. So 81 plus 144, that equals 225. And the square root of 225 is 15. And there it is. The direct distance between the two rooftops is exactly 15 meters. Which seemed like this totally impossible thing to measure just a few minutes ago became a simple step-by-step calculation. All because we found that hidden triangle.
Pretty cool, huh?
So what's the big takeaway here? Let's recap. The Pythagorean Theorem is your go-to tool anytime you need to find a missing side of a right-angle triangle. The magic formula to remember is a squared plus b squared equals c squared. And don't forget, c is always the hypotenuse, that longest side. But most importantly, this isn't just some abstract thing for a math test. It's a real, practical tool for making sense of the world all around us. So now that you know the triangle's secret code, I'll leave you with a question. Just look around you right now, at the room you're in, the street outside your window, the world you move through every day. Where are you going to spot the next hidden right-angle triangle just waiting to be solved?